Hi, this is Ethan Liu, and this is my final project for ENME 435 remote sensing. The original target that I selected was the testudo in front of the McKeldin Library. However, I was having a hard time getting a clear scan of it. I asked the cop nearby if he was okay with me spraying some foot spray on the target to reduce the glare and increase the transparency of the red line on the Raspberry Pi camera. However, he said that he would prefer me not to, so I ended up not doing it. I ended up changing my target to the care bench near chapel because it was dark and the bench didn't seem to have the reflective properties that testudo had. For this project, I got a Raspberry Pi 3 Model B, Arduino Uno, Raspberry Pi camera, and a line laser. Everything was put together on this LiDAR mount that was 3D printed at Terrapin Works. LiDAR is a method for determining ranges by targeting an object or surface with a laser and measuring the time for the reflected light to return to the receiver. By putting the data received from the light detection and ranging device, you can create a 3D point cloud. This method is used in some cars to help prevent accidents as it is not dependent on natural light like how a normal camera would work. Here's my LiDAR mount that I 3D printed from Terrapin Works. This cost me an entire $10.50. On this top half, you can see the Raspberry Pi. I did need to 3D print them in two halves because the entire mount was too large for the 3D printer they had there. I used super glue as the epoxy, and the bottom half consists of the Arduino and the laser. In this case, the laser is the transmitter, the camera is the receiver, the Raspberry Pi is for the data and software, and the Arduino is supplying power to the laser. In this case, the laser is connected to a pin 10 and ground, and I have a simple Arduino code where I plug in the black wire from the 5 volts to the pin 5. It'll supply power to the laser. And as you can see, the laser will turn on. It's on the wall. Turn on, and when I unplug this 5 pin, the laser eventually turns off. There. So, and the reasoning why the camera and the laser are 12 inches apart from center to center is because we're going to triangulate the range of the target we selected, and we are using a distance of 12 inches in our triangulation calculation later on. And I first needed to calibrate my LiDAR sensor. I started by mounting the LiDAR assembly to a tripod and making sure that the laser was aligning with the green calibration lines in the program. You can see that the red line does align with those green lines in the image. Hello, I am Ethan Liu. This is here at McKeldin Testudo, where my LiDAR setup is right here. Yep, I'm just gonna do this side view here because on this side there's a cop and he's flashing his lights on that side. So I'm thinking of just doing this side, thinking of going a little bit lower. Maybe I'll be able to detect these ridges from right here, and then as well as like all the ridges up top. There are some stuff that are kind of placed along Testudo, and probably won't pick those up, so it'll be behind the limbs. But as for right now, yeah, that is the plan. Yep, LiDAR setup with the Arduino, my battery pack taped onto the side, and my phone is going to go right here where it's going to be able to tell the angle degrees. So, yep. So this is my code. It's basically the same thing from question 3. I did have to change the color lower values of it to make sure that it was able to kind of filter out the noise again. But the only thing that's different is this line here with where it's pulling the images from. So I have my Testudo pictures, and then I'm now putting it in the Testudo results folder. Okay. So this is the plot. I opened this by hitting this open folder and the test results here. And this is the plot that my one side of the Testudo gave me. As you can see, it just didn't really pick up Testudo at all. For the actual like project, I think I'm gonna try to buy some foot spray like that one girl recommended in the YouTube video, as well as like getting some black sheets. But I didn't want to do that at the moment because there were cops like right next to me, and I didn't want to like deal with them. But yeah, you can see some dimension on the side of the wall. So the platform that Testudo's on looks pretty good, but yeah, the Testudo itself I couldn't really see, and I couldn't really pick up. I think I'm probably gonna go over and ask the cops so I don't get in trouble. But yeah, this is everything that I have so far. Hey, this is me. I'm at a new Target. I'm hoping you can see me because the cop said I couldn't spray some foot spray on it, and I was not getting a reading on the Testudo at McKeldin. So this is my new Target. It's a care bench, and yeah, here we go. It's really dark over here. There's no lamps or anything, so it should work. The red line should show up very visible, and hopefully I'll be able to have enough space on the right side or the left side as well as the back if I put it like kind of in the bushes to get a full 3D spot of it, and hopefully I'll be able to see the inside of it as well. I'm hoping that because I have a lot of space back here that I will be able to get it all in one frame rather than having to do like a couple letters at a time. So let's see what happens. I'm gonna go through how I went through like the translation and rotation process. So this is the whole thing overall. If you look at it from this side, you can see that it says care. It's the care bench. So this is the C right there, A, R, and then the E. You can see the E from this side. I couldn't get the back side because there were bushes behind it, so it's not like a full 3D cloud. However, I did have to take 4 different scans because of just the C and A, just the C side, just the E side, and just the R and E for the care. But so what I did was I went to the edit. As for making the colors, I want to take the colors and do the height ramp and click the default, and that only works if you click on it. So I click on this, and then I go to the colors. It pops up right here, and then I can just hit default. Yeah, so that just works like that. As for like the rotation, this is actually all of it combined. So like I said before, there were 4 different TXT files, but it took me a hot minute to finally put them all together. But so what you do is you would click on like the one, and you would hit edit, translate, rotate, and here you'll find the rotation of X, Y, Z, and then you can see how before I was using increments of 4 for the rotation and increments of 2 for the translation itself. So what I did was if I wanted to translate along the x-axis, I'd check this off, and then I'd have to turn this rotation off, or else it would rotate it while I'm translating it, which I don't want. I just wanted to do one at a time. So if only X, only Y, and only Z. And then if all 3 were off, it would only do the rotation. And then you hit the forward and backwards. So I'm going to demonstrate that with the whole thing right now. So if I did 1, I did backward, you can see it like moving like that. So, yep, that is how that worked and how I got this to spell out care. So here we go again. This time we're gonna do the 3D mesh, and so the first thing I did was I clicked on the one I wanted to work with, clicked on edit, then I went to normals and compute. So when I hit this compute button, it turned this like on this side it's like black, it turns the color black. And then the next thing I did was I went to plugins, and I went to the Poisson Recon, and when I clicked that, I made sure that the output density as SF option was selected. Maybe I can do it again. Poisson Recon, yep, as selected, and then when I hit that, this mesh showed up. This mesh showed up.